Hi, I'm Douglas Foe from the Diehold Foundation, and this is in Series 1, Part 9. And we're going to cover these two subjects. One, can there be a black hole in the center of a quasar or galaxy? Now, I know the previous video, Part 8 in the series, I covered the miraculous transformation of Stephen Hawking at the end of his life. He didn't believe there was any black holes either. But it has to relate with the second one, can a galactic superwave cause a star to nova? The reason I got suspicious about the idea is because it didn't seem there was enough intergalactic dust to actually cause a star to nova, and certainly not periodically like clockwork. So I'm going to be teaching from God's Judgement book, Theory of Multidimensional Reality. You have to basically know to understand how the universe really works. The other one is Hebrew alphabet, and you'll understand why later when I get into this thing. It's the model that creates the Hebrew alphabet. That model is the same model for everything else. Anyway, this is besides the books, these are some of the research subjects I went into, or topics. Now, all these titles of journal articles were presented by various presenters who believed this idea. And so I went through all of them, read them all, and even additional some video that other people had that they were referring to. And quite a few of them. The ones that are highlighted in red, I'll go into more. This guy, E. Parker, was really the first to come up with the idea of interstellar gas, and I'll explain why when I get into his stuff. And then finally, cosmic ray volleys from the Galactic Center and their recent impact on the Earth. This guy, Paul Villolette, owns a Starburst Foundation. He's really the one in 1986 who really presents and try to present this idea. Pretty weekly, I've read his papers and I've got them. And I'll go into it later, but he's really the one who started a lot of people thinking like that. Now, of all the papers I did, just like I did with Stephen Hawking's, I looked for conditional statements, or I expanded it from what I did with Stephen. I searched for if, could, assume, may, might, possible, possibility, provided, suppose, and consider, and a few others. When you sort of read their papers, they kind of say the same thing but differently, but you realize what they're doing. This is what their idea is. Now, this model here is really based on a solar model that when the sun gives off the solar wind, cosmic radiation, stuff like that, it goes out, and remember, it's rotating at 27 days per month, and it sends off the solar wind in this kind of direction and this kind of thing. So they're thinking that these are spaced galactically about 12,000 light years apart. And this is called a galactic Radcliffe wave. Supposedly this winds up hitting our solar system and triggers our star to do something, and something on the Earth too. Now, these are also the names I saw. Now, I sent this list of names, a few others, to my friend Ben Davidson at Suspicious Observers. And he went through some of them, and so basically it goes by multiple names, which is kind of strange to me. In physics or geology, you don't normally do that, but they do in this particular subject. So I'm going to give you some background history so you understand where I'm going with this, so you understand two things. You're going to know there's no black holes in the center of a galaxy, and you'll see how easy it was for me to prove it. Dr. Schwarzschild, PhD, German physicist, he wrote a paper about a month after Einstein came up with the general theory of relativity that was saying that that you could have a black hole. You have infinite gravity and everything's going to suck in, and that's it. So these are some of the things in physics that they didn't know, and they had to come up with a solution. This was the first one, of course, was discovery of quasars in the 1950s, 60s. And when this guy Parker was writing, I kind of forgive him because he didn't really focus too much on quasars and what they looked like. Certainly when a Hubble telescope was put up in Chandler, we got a real good look at the galaxies and quasars. And we understood what was going on and how the stars are formed. But this is one of them. And the output of these quasars were huge. They couldn't explain things like this. Out of 500 million of our suns per second, it means physics was a real problem, had a real problem. They couldn't explain this. And it would mean that by the time it was producing stars out as far as we are from the center of the galaxy, you'd have no more hydrogen, helium, and a whole bunch of other elements. But that was impossible. So they had a real problem. They were looking for a solution. Along comes Stephen Hawking, and he gave them a solution. They jumped on it like flies to you know what. The other one is about black holes and quasars. If quasars were powered by a black hole in the center, then what formed the black hole before it became a quasar? They don't talk about this one too much. You can understand why, but we're going to go into it. You'll know the whole truth. It's going to surprise you. This should be one of my better videos. Okay. Do we know what a quasar looks like? Yeah, we do. Some of these guys didn't because they didn't have pictures of it yet. But these are examples here. You got a quasar, extremely bright object, and it shoots off two jets. Now, I'm going to go into some of these pictures will have multiple colors on them, are composite pictures of X-rays, radio, optical, and sometimes a couple of bands of other bands of radio. But here's a quasar, and you see the beginning of the galactic arms showing up like this. It's the beginning of one. Here's another one. Something's going on here. From here, you have these two jets. Now, this is probably the radio noise. I think they do the radio noise, or was the X-ray in red, but we'll find out in a second. Here's another one. Two bursts of energy, and the cloud is probably, this is where the stars are being created out of a center. Here's an example of the composite. Here's the composite with X-ray image, red. The blue is an optical. The radio is a darker blue purple. They combine all of these to come up with this. So some of the pictures are going to be a little deceptive unless you know what you're really looking at. Now, what I've done is on hundreds of galaxies and quasars, I blew up the center part and I dropped down the brightness all the way down in Photoshop to see what I was going to find. And all of them, I have a very bright spot in the middle. Something's going on here that's creating this. This is radio noise, but I guess the galaxy and the matter is being formed, I guess, along here. So here's some examples. Here's another composite picture, multiple colors, but the blue is X-ray, optical is more white and yellow. They made the radio signal green, another radio band, 21 centimeter, kind of that pinkish, brownish color. They combine them all and you got a nice pretty picture. But it's what's going on in here. This is where the stars are being formed, and this is really radio noise is what you got here, and X-ray material. Here's another one. You'll notice you have the streams coming out horizontally, like on the galactic plane, and then you have this vertical line here. This is blown up here, 90 degrees out of phase from when it's creating matter. Phoenix quasars, same thing. Here's a blow up of the center. This is where the action is. This is going on. Something is going on here. M51 Galaxy. Here's a blow up of the center. Then I drop the brightness all the way down. Now the line represents through here. This is where the stars are being formed. Now there's nothing in the mathematics for black holes that say a black hole has a preponderance or tendency to release matter 180 degrees opposite each other. It just isn't there. But here we see it in all the galaxies, every one of them. So matter or stars are pushing out this way, but you get this very bright spot here. Here when you drop the brightness all the way down, you see a little better. This is kind of like one big plasma and very bright white area in the middle. And if you remember my video in Series 1 on what light is information. When you have that much light and output of light, that means a tremendous amount of information is being directed to a small point in time and space. But no place here do you see a black hole. No place. Here's another galaxy, NGC 11365, and I blow up the center, and something's going on here, and it's shooting stars out in this direction. This is wrapped around like this, and it looks like this one goes that way. There it is. Another galaxy, quasar rather. And you see the arms of the galaxy just forming and going in this direction. Looks like it's counterclockwise, but the thing in the center is rotating. Drop down the brightness all the way down, and you got a bright spot right there, and it's shooting out stars on both sides. By the way, you have quasars that are 10, 20 million light years away, a billion light years away. You're not looking at dust. That idea that a star comes from dust is nonsense. You'll see it, I'll prove it to you in a second. But you can't see dust that far away. If you're seeing this stuff, it means there's stars there. Now the star produces dust, which I'll show you later to refresh your memory from Series 4. Those glass beads and particles like that, when they nova every 12,068 years. Here's another one, Quasar 4258. Here, the arms of the galaxy forming in this direction, and there's your spot right there. Whatever's going on here is where the magic is happening. M83, same thing. You can clearly see it from here. You've got two streams of stars coming out like this. Here's the blow-up, something very white in the middle of this thing, and it's blowing stars out of nothing. No black hole again. This is an artist's concept of a black hole and a big dust shell around this thing. They don't have black holes to photograph, they got this one. There was a story about a black hole being formed, and one professor, can't remember, Rotalia, had a video on it, and it's basically fraud. They had too little information to even make that picture. And I covered it in the previous video in part 8. Watch the part 8, you'll see what I mean. Okay, here's galaxies. A few of them, I'm not going to bore you with too much of this stuff. Same thing, all coming out from a center point, a very bright center point. Now we go into the evolution of a star. We're going to go think this forward and then backwards, and you'll see there are no black holes. Supposedly a star, this is what is taught in school today, what's believed, that a star is formed from condensed dust and atoms in the universe. It condenses down by mutual gravity, and eventually it forms a star. Nobody says how many billions of years that takes. One article that Parker was writing, he was trying to figure out what formed the arms in the galaxies. That's what they were trying to figure out back in the 60s and 50s. That's the reason for his article. And he trying to figure out why, or can you have a tubular magnetic field, how does gravity affect it to get these tubes of stars? So that's why. But again, in his papers and the others, they all say a star is formed from intergalactic dust like this. So this is the common theory that we are taught in school, accepted one. You have a nebula, like what I just showed you. Now, if it's not too much material, a main star like ours, red giant, planet, it has a nova, planetary nebula, and then goes straight to white dwarfs. It's kind of shock for them, for me to come along and say, yeah, stars doing this every 12,068 years. But of course, this is their theory, so I'm going to repeat it. If it's a lot of dust, it creates a main sequence star. Now, it means this dust has to equal the mass of this star. And let's say it's a real big star. So they say it becomes a red giant, then it becomes unstable, loses all its hydrogen and helium, and it blows its brains out, and depending on its weight or size of the mass, it's either a neutron star or the beloved black hole. So let's look at the logic here. Intergalactic dust has to be equal to the star it creates, which is greater than or equal to when it becomes a really big star and it's burned off most of its hydrogen and helium. They provided this lovely graph. It's an iron core, and it's got the different things that's going to burn up: hydrogen, helium, carbon, oxygen, neon, magnesium, silicon. Now, eventually, this thing's going to be mostly iron, and at some point here, depending how big this sucker is, it goes supernova. We love that, don't we? We love those supernovas. They're so pretty. So, and it has to be equal to or less than that, because it's going to burn off energy and stuff like that, and therefore, it's not going to be the same. It's going to be a little bit less mass. And this is the same thing. I draw a black hole on a nebula. There's my black hole. And that's equal to our drawing that the artist was so kind to do for the astronomers. They have something to look at and worship. So, it means the black hole that's supposedly in the center of a galaxy has to equal the mass of all these stars that came out of it, which I showed you. There's no question the stars are coming out of the center of a quasar and forming a galaxy. But this has to equal the mass of all of this. You got that? It's not sucking in anything, great gravity. Oh no. It's pouring stars out of it. But it means, by their logic, this has to equal that. Okay, so let's go look at galaxies. This is where their theory becomes totally absurd and preposterous, to the point of laughter. Here's our little Milky Way. It's 170 to 200,000 light years across. 250 billion plus or minus 150 billion. The numbers I usually see for our galaxies are about 150 billion stars. So it's around there. It's a lot. Mass, 890 billion times the mass of our sun. The center, a supermassive black hole of 4.1 million solar masses. You say, wait a minute. The black hole has formed this galaxy, but it doesn't have the same weight as the weight of all the billions of stars we think that are in the Milky Way. Gee, how can that possibly be? So, because in the matter theory of existence, you can't create matter out of nothing. That's a problem they have. Second one, Andromeda Galaxy. 220,000 light years across. Distance, 2.5 million light years away. That's 1 trillion stars. Obviously, there's an estimate. No one's sitting in and counting them. The mass, 1.5 to 2 trillion solar masses. That's a big puppy. Center, the mass of a core black hole, 140 million solar masses. Again, this doesn't seem to add up to the trillion stars or masses here. 1.5 to 2 trillion masses. How come the difference? 150 solar masses? Obviously, they're guessing all these numbers. M87, 980,000 light years away. Distance, light years across. Sorry, that's diameter. Distance, 54 million light years away. Over 1 trillion stars. Pure guessing. Mass, 2.4 trillion solar masses. So you figure it's got at least 2 trillion stars. Center, massive core, black hole at 7 billion solar masses. Again, wait a minute. The black hole created 980,000, 1 trillion, maybe 2 trillion stars, or 2.4 trillion solar masses. How can 7 trillion solar masses make 2.4 trillion? Doesn't make any sense. My God, they're actually trying to say it's created matter. But they can't do that with the matter theory of existence that they're married to. This is the granddaddy of all. This is the biggest galaxy we have ever found, IC 1101. 6 million light years across. This sucker is big. It's about 1 billion light years away. Over 100 trillion stars. Mass, 250 trillion solar masses. Center, massive core, black hole at 40 to 100 billion solar masses. So they're trying to say, let's say the 100 billion solar masses created 250 trillion solar masses. You can see right off the bat, I have a problem. Now, remember what I said in the previous one? This has got to equal that. So I guess the question is it's obviously, we've never seen solar, intergalactic solar dust to equal 250 trillion solar masses. Doesn't exist. We've never seen a star, one single star. You have to have. You got to have a star to create the black hole. That's been 250 trillion solar masses and greater, because remember, this is after a lot of burning up. So it's obvious there are no black holes in the center of a galaxy at all. Never was, never will be, because I just went through the logic. It's unassailable. Have a black hole, you have to have a star on the other side and a dust cloud that's equal or bigger than the black hole it created, and the black hole is creating a galaxy vastly bigger than its own mass. Makes no sense, especially since we've seen quasars. I showed you. You could look on, they think there's over, they clocked over, I didn't say clocked, they've mapped over 200,000 quasars. And they all have stars coming out of it. Simple as that. You see the stars. You see the various stages of the development of a galaxy. Star and black hole cannot equal that. Basically, that's it. There's no way. What I've just done is destroyed astrophysics. Now, I'm going to tell you something important. If I could figure this out, don't you think a bunch of astrophysicists and physicists also could figure it out backwards to realize what they've got is crap? Of course they did. And the question we're faced then is, why are they lying? Oh yeah, grant money, which you have to get from the National Science Foundation, and I proved in one of the earlier videos, I think in Series 4. Guess who controls that? The CIA. And they don't want anyone to know the star novas. That's what's going on here. Here's our poster child for black holes. Like I showed you, there was a footnote in this paper he did that referenced holograms. And after that, he started writing about vector fields in holographic cosmology. He's writing this journal article. Mentions holograms 17 times. 2013. So 2010 he read it. 2013 he's writing articles. 2013. Quantum probabilities of inflation from holography. Goes on and on like that. Same thing, paradox of black holes. This is where he says he realizes it's got to give up matter and it gives up energy and stuff like that. It's not an absolute black hole where everything gets sucked in and you flush the toilet. Here, he was kind of a coward though. He lets this, his last paper, be released, got released a month after he died. He died Pi Day, March 14th, 2018. By sheer coincidence, it was the first day I did my first video video series 1, the very first. It's also the birthday of Albert Einstein. It's his death day. Mentions holograms 28 times. Now, people, I want you to understand something. You cannot have a hologram unless it comes from information. There's two ways to create a hologram. I can go over it in the previous video, but very plainly, you have to have a computer to modulate two reference beams, or two laser reference beams to create the hologram. So he's saying, when he says a hologram, he's saying that these galaxies and stars and planet and us come from, the information comes from someplace else. He's saying it. Fortunately for him, I said it 42 years ago. Okay, now we get to the superwave nonsense. Here's some drawings. This is a drawing of our galaxy, theoretically, an artist drawing. And these are these waves that they envision coming from the center of the galaxy. Of course, they're all assuming there's a black hole, and I just proved there is no black hole there. Something else is going on. By the way, towards the end of this video, I'm going to tell you what's going on in the center of these galaxies, so you understand. I try to give you a whole picture, a whole truth. So, we have a galaxy, and they're thinking that this energy from here comes out like this or like this, and as it hits a star, it has a wave of plasma or dust and gas, and it hits, each paper was a little different. Some think dust and gas, and it varies. Okay, we know what the dust and gas is. We know what the dust is. This is the glass beads they found on the moon, 0.1 to about 1.5 millimeters. Here's the glass beads found on the Earth. And here's the glass beads called Mars blueberries. They found on Mars. They photographed. They didn't analyze them, but they think it's the same stuff. Now, the reason there are more of these because atoms do collect. Now, when Parker was writing his paper, he was saying from 1 to 3 hydrogen atoms per cubic centimeter. That's just probably as close as you're going to get to a perfect vacuum. But he was saying that they could collect their mutual gravity with like 10 or 15 atoms per cubic centimeter. Forget it. These are billions of atoms per cubic centimeter, and they can because it's mass coming out of that star when it novas anyway. To prove the point, here's the Japanese landed on a comet. And what was it? Just like I said in a previous video. I think it was in series 4. That those glass beads, mutual gravitation collected on its way out, it was blown out away from the sun, and it creates these comets. And what the Japanese found was the chemical composition was similar to the stuff they found on the moon and the Earth. Okay, this was Parker's idea from March of '66. Now remember, I kind of forgive the guy because they didn't know anything about quasars. They didn't have very good pictures of them. It was just beginning to come out. And I don't think he really focused on it. He was focused on really those galactic arms of dust or stars. And he came up with this waveform, plasma waves emanating from the center. Now, he doesn't even mention black holes because our poster boy, Stephen Hawking, didn't really publicize it and really bring it to public attention and become famous from it. But he included magnetic lines of force must be tied to the galactic nucleus. But he never says what's going to cause this stuff. But there is a magnetic field in the galaxy. You'll see it shortly. And he goes on, he does indirectly mention here the inverse square law, which a lot of them do not mention at all. They don't even think about it. Now, on the conditional statements, he had a total of 113 conditional statements, which means he's got a loose theory. He's not even sure of it. If statements, may statements, suppose, consider, possible. You can see it's a very loose theory. His math is good, but the premise and the philosophy was not correct. Here's more a visualization of what he was trying to get at. Somehow the arms are formed like this inside this, which is wrong. You saw how the arms are formed. It's being pushed out of the middle of a galaxy, out of the center. Okay, here's his other paper. The interstellar gas which forms the stars. Again, he's wrong about this because he should have known you can't see dust when it's 30, 50,000 light years away or a million light years away. You just can't see it. If it's glowing, then you see it as a star, if you're lucky. A strong magnetic field and a relatively hot thermal gas with Y equals greater than 1 are all combined magnetic field and the hot gas stabilized. He's basically saying the word nova here. That's what caught my eye. I don't think people realize it. What he's saying here is a nova. Again, 68 conditional statements. Again, a very loose theory. Can't really take the thing as being real. If you have this many, you can have 5 or 6 things that are wrong and this whole thing blows up in your face. Cosmic ray volleys from the galactic center and their recent impact on the Earth environment. This is the guy who started the whole thing, Paul Villolette, Starburst. Now, I read his stuff, and he draws so many conclusions that, and he pulls it out of a hat by the number, even trying to say 10,000 to 99,000 years, these galactic waves hit and somehow magically cause the Earth to have horrible things happen. But you'll realize at the end of the video what NASA has found with Voyager 1 and Voyager 2, this is not possible. It doesn't happen. It cannot happen. So that's what this is all about. I'm going to leave it on here. You can read it on your own because I got a lot more important things to cover. But the funny part was this. Oh, these effects in turn disturb the Earth's climate, precipitate mass extinctions, and cause geomagnetic reversals. This is the first time he mentions this. He never says or tries to even attempt to explain how a dust cloud can do that, or even this. He doesn't at all. That's how weak this paper is. It's not really, he's not associated with any college or university. That was obvious from the paper. 115 conditional statements. 150. If 34, could 29, may 40, might. I mean, this is like wishful thinking. Inverse square law, something that most of the papers I'm going to talk about next ignore totally. This is the entire electromagnetic spectrum, including cosmic rays. They all observe the inverse square law, which says the farther you go away from the source of energy, the power is reduced by its square of its distance. And this is actually from the paper. They did a test of it, and radiation test. And the counts decreased as the function of increased distance from the source. That's inverse square law. Gamma rays are produced in the universe by supernova explosions, solar flares, neutron stars, black holes, and active galaxies. They all observe the inverse square law. So if you're 30 or 40,000 light years away from a nova, you're not going to get much effects from it. You'll see it. You're not going to record very much. And it was repeated in some of the papers that NASA wrote and some of the others. That's true. The clock side of terrestrial mass extinction is 205. What was interesting about this guy published from the US Navy. Now, you know my feelings. The military know the truth. He only had 2 conditional statements. And he went through all the different possibilities. And he said that an impact, you know, that Luis Alvarez was trying to say that whacked out the dinosaurs, their impression of the Defense Department was deep impact when analyzed, quote, showed the resulting damage is too localized to adequately explain the global nature of the end Cretaceous extinction. Didn't I say it? I said that in the videos on comets and stuff like that when I covered it. It's just, it's not like the movie 2000 and, what was it, 2010, 12, or Deep Impact, or one of them, where it shows this fireball surrounding around the entire world. It's not like that at all. Too localized, and even the Navy knows it. So he goes in here also, and he realizes the well-defined cycle could be a major, large nova and a megalithic cloud caused by it. But you'll see that's just not possible. He went through, and of the major extinctions in time are about 65 million years apart, and he goes through them. Supernova, deep impact, supernova, deep impact. And these are the possibilities that it could only be. Now, when he says deep impact, he's assuming, he came up with the idea, if you had a meteor that could be big enough and fast enough, could penetrate the Earth's crust and go into the mantle, then somehow it would cause volcanoes going off all over the world, and that would cause the mass extinctions. But as far as I know, it has never happened. Not in all these time cycles he's got. There's no evidence of it. These are the other papers. I'm not going to go through all of them. You could see some of them had absolutely nothing to do with a dust shell going through time. I don't even know why they referenced them. But what was revealing is the number of conditional statements on these things. This is supposedly in the center of the galaxy. Supermassive black hole there, supposedly there. Anyway, they're assuming X-ray flares and stuff like that from the center. 52 conditional statements. Consider 31. What if I don't consider it at all? It means this paper's not worth wallpaper. Cosmic electric current and the generalized Bennett relation. Again, 63 conditional statements. No mention of black holes, Milky Way, or dust shells. So I don't know why the person even referenced it as a proof of this dust shell hitting our solar system and causing a disaster. I don't understand it. Dynamics of Parker gene instability. Well, Parker is the guy who, in 1966 and 67, that guy. And this paper was just done recently. It goes in here. The bulk of cosmic rays in interstellar medium is low energy, below a few hundred millivolts. As they travel through interstellar medium, they lose energy via ionization, also inverse square law. Interstellar medium dust, the effects of the cosmic rays on the interstellar medium. Paper about self-gravitating disk, 20 conditional statements, which isn't too bad. Galactic cosmic ray modulation of the passage of the heliospheric, helio means their sun, current sheet at Earth. Again, no mention of black holes, nova, or galactic center. Remember again, the only reason I'm mentioning some of these is because they were used as references to proof that a galactic sheet is going to hit us and cause our sun to nova, which made no sense. Here's another one, 45 conditional statements. No black hole in the binary system, nothing to do with dust clouds in the Milky Way. So why mention it? Nuclear ignition of white dwarf stars, again, about white dwarfs near a rotating star, but never mentions the galaxy or dust or gas. So why did the person, 46 conditional statements, why did the person even reference it as something to prove his point? Structure of the outer galactic disk, again, 20 conditional statements. Nothing about black holes, center of the galaxy, or the stellar disk. The effect of magnetic fields are probably on the circumgalactic medium. Increased magnetic tension. He's trying to figure out how the arms are created. Parker did the same thing also. Okay, decrease of the relative velocity of clouds and their background medium. 27 conditional statements. Okay, this is a Radcliffe wave, but it really is what you know now. It's what came out of the center of the galaxy, and it's a whole bunch of stars. There's no dust in this thing, except the dust created by the stars when they nova every 12,068 years. That's the only dust here. We're us. There's our sun right there. And this is the arm we're in. Kind of an offshoot of one of the Sagittarius, I think it is. So I wanted to know, because they would keep mentioning about a plasma coming out of the center, or X-rays, and coming around and reaching us. Now, this is from the center of our galaxy. By the way, this is an artist's rendering of our galaxy. It does not look like this. We don't have a picture of it. And they show this opening way too big. I don't see it on any of the galaxies. This is our sun right there. Supposedly we're about 27 to 26 light years away. So I used their scale. This is 10,000 light years. And I measured pixels in Photoshop to see how far our sun came when it came out of this center of this galaxy. It went all around like this. 20 stages, and then 21st is in there. I added it up. Comes up to not 26,000 light years, but 26,000 light years, but 155,000 light year long. Gee, use the inverse square law on anything coming out of there till the time it reaches there, if it was only in this arm, and you realize how little energy we're getting if that was the case. Here's another example of it. And again, we're right there. So this graph was done by my friend August Dunning. And he took my database, I gave it to him of 550 stars, open clusters, and globular clusters. And because he wanted to check to see if I was right regarding the 6 blank periods, and sure enough, this is what he gave me. And he didn't use here's the galactic plane. He didn't use the stars that were up there, above it, above so many, because if you know trig, you'd wind up being in further than you really are because you're dealing with a circle, really. So I took the ones and I just marked where it was. Now the black areas are the black areas where no stars are visible. And you can clearly see this is based accurately using pixels and using their unit of measure. That sometimes the bars where there's no galactic stars at all are very few. So here's the truth. This thing's happening on a clock cycle. It has nothing to do with anything in this dimension causing a star to nova. I think that's the whole purpose of what they're trying to do with the government is to try to promote the idea that go look for something inside the galaxy that's been created rather than a clock cycle. Because the clock cycle is definite and they have no control over it. They rather have the chance they can say, well, this wave is not going to hit us for 500 or 1,000 years or more. And that way it placates them all while they build shelters and tunnels in places they shouldn't be, because where they're building them, they're not going to save themselves at all. Now, some of the similar lies, because there's no question what I just showed you with black holes is a lie. If I could figure it out, I'm sure PhD in astrophysics certainly has figured it out also that something's wrong. But it has to do with, one thing we learn in accounting is follow the money trail. And like I mentioned in one of the earlier videos, the problem with science is that right now is that they are forced to go apply for grants to do papers and research. So the school administrators get the money. The National Science Foundation only lets the professor get 2 months' salary of, let's say, $1 million or $2 million grant. The school could take 50% for overhead. It's to self-ingratiate the school administrator. So it becomes obvious that the National Science Foundation grants are really political payoffs to school administrators. That's the truth I figured out and realized what's going on. It's a corrupt system. This is the other lie. I mentioned once on the video in Series 4 about the oceans. Someone was doing a paper on the fields, the canyons in the continental shelf. This is the continental shelf here. But he stops right here because he can't explain any of this. Like, don't look here. Don't look at the guy behind the curtain. This doesn't exist. I explained this and up, and you are not concerned with this at all. The phantom leaf effect in Kirlian photography. I know the Brazilian Institute guy who did this. So, and I know Thelma Moss, the late Thelma Moss, and I know these pictures are good. And what this is, it proves that this is the matter part of the leaf. The leaf is cut off in Kirlian photography, and then they photo immediately. And the conscious part, what we call the soul of the plant, is still modulated to the same coordinates in time and space. Same thing here. You can still see the outline, the bubbles of light that makes up the consciousness or the information that makes up the whole leaf in the Diehold. And it's still being transmitted, but in a few seconds. It lasts about 4 or 5 seconds and then fades away. Why all the lying? I've shown this a number of times. This is from William Casey. He's the head of the CIA during the Reagan administration. The first meeting they had with the president in '81. We'll know our disinformation program is complete when everything the American people believes is false. What the scientists didn't realize is that's how they were doing it. They controlled the National Science Foundation, and I went through some journals that they control, and you realize, uh-oh. So that is why you have a matter theory of existence. That is why you believe that there's a black hole in the center of all galaxies, and that stars, big stars, become a black hole. But you're never to believe that stars nova repeatedly like clockwork, because it is a clock cycle. You're never supposed to believe that. This has been reported by George Herbert Walker Bush, Mr. One World Government himself, CIA director in '76 to '77. Sarah, if the American people ever find out what we have done, they would chase us down the street and lynch us. Now, some people say this is not a correct quote, but I did read from Sarah McLinden, who was told it, and she says, yeah, he said it. So anyway, Stephen Hawking, even he knew at the end of his life there were no black holes. But this is the key part here. A full explanation of the process that physicists admit would require a theory that successfully merges gravity with the other fundamental forces of nature. But that is a goal that has eluded physicists for nearly a century. The correct treatment, Hawkins said, it remains a mystery. Except now you have the theory of multidimensional reality explains it. Very easily, may I add. Okay, now we get, why did I mention this? And we're going to get to explaining what's going on in the center of a galaxy. Why do we see billions of stars pouring out of an area that's only about 1 astronomical unit, which is basically the distance from our sun to us, 93 million miles. Now, I'm sure some are wider than that, but that's what they write. So, a very small one. So I'm going to give you some analogy and give you, this is to show also the reflexiveness in the universe. You and me are a product of the universe. We are a reflection of the universe. Therefore, our components, our inventions, and things like that are also reflections of the universe that we are part of. The people who came up with the 22 symbols on those 2 tablets that Moses pulled out of a cave were literally tens of millions of years more advanced than us. They knew how the universe really worked. We don't until now. This is the model that I used. Here's the wire model I created. Oh, I'll go back and my hand hit the button. This is the wire model I had to create to do it. So, what do we got here? We're going to go from the atom all the way up to the universe, and you're going to notice it's the same program. This is one of the earlier pictures of an atom. I can't remember which one he used, but this is what's going on here, and this is the electron shells. Here it is too. Here's a more recent one, a hydrogen atom, 256 picometer diameter. That's like trillions of a meter. And this is where all the action is happening, is right here in the dead center. And these are the electron shells around it. This is the key part. This is the graph I used for this, and they must have also. The top one, the y-axis, is the information, the carrier wave that carries the information that makes up that one atom. The left and right is, well, this could be a proton, that could be a neutron, or vice versa. When I looked at it, I said, that's Planck's constant, but it's also what we call our matter world. This is an important, from this you could figure out everything what's going on, and this model. Okay, we go for the galaxy. They know the galaxy has a magnetic field that covers the whole entire galaxy. This is the Torade model, which is important. Everybody who deals with physics and electronics knows the importance of a toroidal field. Here, this is one of my models from the Hebrew alphabet. This is the Resh. And when it crosses the x-axis, which is right here, either on the inside or the outside, it then creates a spike, which is that matter. This is an artist drawing of our galaxy. I don't think it looks like a balloon. I think it's probably more like fluted up like this, rather than this two balloons they've got going on here. But this is the galactic plane where all the stars are. And this is the dead center. But it's an artist drawing anyway. Okay, go to the atom. These are gold atoms. Please note, what we're looking at here, the outside of this thing, is really the electron shell, not the center of it. There's the center of that hydrogen. You're looking at this shell here, not this. This is so tiny compared to the outside shell that it creates. But notice the shell prevents other atoms next to it from encroaching in it. They bump against, they touch, but they don't overlap each other. That's important. Keep that in mind. Here's our graph again. This is the pay. The Hebrew pay is this one right here. Here where it crosses the x-axis on the outside, and it would cross it right here on the inside. See? Every place where it crosses, it creates it. Here's our Earth. We have a magnetic field, and it creates a toroidal shape around it, and it protects us from cosmic rays and the solar wind, particles and stuff like that from the sun. Keep that in mind, that our magnetic field protects us from solar particles as well as cosmic rays and other things. What's going to happen during the polar reversal? We don't have a magnetic field for about 7 or 8 hours. God knows. It's not going to be pretty. Here's another picture of our dear sweet sun. This was done by, I think, NASA. And they're showing a toroidal field around the sun. Now, take it a little further to our whole galaxy. I'm sorry, not galaxy, our solar system. You got the sun here, and it basically has a big toroidal shape. The same shape that's going on in the center of a star, the center of a planet, and the center of an atom. It's the same model, the same program. Now, this magnetic field, thanks to Voyager 1 and 2, recorded this. Here's our sun. The solar system you can barely see around here, but it creates really a toroidal shape. And it keeps the intergalactic wind or particles from reaching us. That's why the idea of intergalactic particles hitting the sun or the Oort cloud or something like that is nonsense. The magnetic field created by our sun protects us. Of course, they wouldn't have known that unless they researched it. But it was discovered by Voyager 1 and 2 when they finally got that far away from us. Sun's magnetic field protects the solar system from the interstellar medium. This is the same model and program how the atom comes into existence, no difference. Just like the electron shell around the atom prevents another atom from encroaching on it, keeps it at bay. It looks like the magnetic field from the center of our sun does this exact same thing, just like the magnetic field in our own Earth protects us from solar winds and solar particles. Here's another more dramatic picture that NASA created. Even though the interstellar medium has a low density, it still has a pressure similar to the air pressure. The solar wind also has a pressure. Close to the sun, the solar wind has a large pressure and can easily push the interstellar medium away from the sun. So these people that wrote those articles that, oh, we're going to have this intergalactic dust hitting the Oort cloud and creating comets or knocking the comets out, and they're going to hit the Earth, or once it hits the sun, it's going to have additional particles and it's going to nova. It's all bullshit. It's all wrong. Complete and total wrong. Further away from the sun, the pressure from the interstellar medium is strong enough to slow down and eventually stop the flow of solar wind from traveling into its surroundings. The entire area or bubble inside the boundary of the solar system is called the heliosphere. And there's our heliosphere here. And this is where the solar wind comes in contact with the intergalactic dust. So it doesn't really hit us. No, not very much of it. We'd have a better chance of, if it was star nova and it was like 10 or 12,000 light years away, we get it. Okay, now for quasar in the center of a galaxy. This is why I actually tell you what I think is going on here. Here we got our toroid model. We have a center modulation point. We do not have a black hole there. Again, this is important. Why do you have two jets of matter coming on from both sides? Look, when it goes, imagine an imaginary here. The magic is happening right here. This is where it's happening. The reason why it shows up as a toroidal shape is because it's like the Diehold has to stabilize the creation. So there's no tear in the universe. So when it modulates and gets a point to create a quasar, in turn a galaxy, it stabilizes it with this magnetic field. It opens it up. So the center looks like this. You want to know why nothing's happening here? It's because in this area here, there is just so much information that make up whole stars that they can't even quite exist yet. There's so much plasma. There's like 4 states of matter: solid, liquid, gas, and plasma. A lot of voltage. And it can barely exist until it gets far enough away from this center modulation point. It's almost as if when I explain how the universe worked, there has to be something in this Diehold that's like our video cards. Our computers have the information for sound, color, light, shape in different parts of the computer. Just like the Diehold would different information for the elements that make up these stars, the consciousness of the star, quote unquote consciousness of the star, how it works, everything, with different parts of the computer, different parts of the program. So our video cards takes all this information that we generate in a computer to create a moving image that you see. Well, the Diehold must be doing the same thing here, but we're seeing like the beginning of actually the equivalent of what this quote-unquote video card, remember, it's just an analogy, the thing that puts our reality together. And it opens this thing up. It has so much energy, has so much information pouring in there. That's why it's a white dot. That those stars can't really start forming. When I mean forming, I mean they start actually being something, and they can start producing matter around its shell that makes it a star. So it's a massive center modulation point where the Diehold says, okay, I have too little information in this creation, the universe. I'm going to open up and create a quasar, what we call a quasar, that we can create a galaxy in that area. In other words, I'm also saying that I don't think you can get one galaxy going into another. I don't think it's possible. I think just like our sun and does with our solar system, and the Earth does protects the Earth from solar wind, I think it's possible that this thing keeps another galaxy from interfering and coming into the thing. Now, there may be error in the universe. You may have one or two like that, but I think generally, I don't think it can have it. So this magnetic field, this is like this, but this is what's really going on is here, and the galactic plane would be across like this, and this, obviously this is continuous over magnetic fields. Came across this. This is a representation of a three-dimensional magnetic field due to four currents threading at the center of each helix of a shear Alfvén wave. And I think this is what's happening in the center here. There's so much information. They did four currents. Well, you got a lot more than that going in here. And you wind up with different waves, these Alfvén waves, going in and coming out. And that's probably the reason why you have these jets of X-rays and radio noise coming up and down perpendicular to the galactic plane, which would be down here. All in there. And that's probably the other reason it's so excited, these stars can't exist until it gets far enough away from its center modulation point. Now, the other part is this. Just like our solar system revolves around the sun, but the sun revolves faster every 27 days, if I remember correctly. I think this thing does the same thing. The center is revolving faster than the arms of the galaxy that it creates. So in the center it's going faster, but the outside it's slower. I think the reason why, let me go one more. The reason why we see this like, we're going like this is because the magnetic field itself is the thing that starts twisting the information as it comes out of the galaxy, as it goes straight and then starts rotating. I think the magnetic field itself is the thing that's causing the thing to rotate and do the circular arms. It was acquired at an instant of time throughout the volume of a large 60 centimeter diameter, 18 meter long plasma in the LAPD device at UCLA. The current and the field topology change in fractions of a millionth of a second. The sparks are proportional, these are the sparks in here, proportional to the electric field in the plasma induced by the wave. And this is actually a picture of the wave. So what I'm saying, and here you have perpendicular to what you'd say the magnetic field, or where the galaxies, the stars are being formed, you have this radio noise, or this plasma propagated perpendicular to the galactic plane, would be like this. But they did the experiment at UCLA, thank you, and there's a lot of high voltage going on in here. And this is what I think is happening in the center of the galaxy. So in other words, no black hole. Diehold opens up a toroid shape stabilizing device, and all of a sudden, from the center of the toroid, it pours out stars, billions upon billions of stars. So you got quote unquote matter coming from nothing. But it is something. It's coming from the information that makes the whole entire universe up. That's the difference with the theory of multidimensional reality. You can't explain what you see in quasars and galaxies with this matter theory of existence that, unfortunately, they're stuck with, thanks to Aristotle and the Pisos. I hope you enjoyed it. I think I answered some important questions for everybody. And, you know, with a 501c3 foundation, the money's used to basically pay for subscriptions to nature, science, geology, and a whole bunch of other stuff. Eventually, I'll save up enough to be able to do another expedition to the Sinai. Anyway, I hope you learned something. Hope you did. And now you know there are no black holes and there are no jets of waves of dust coming to get us from the center of the galaxy.